Wherever you are in the world, whatever time it is, there's something deeply humbling about gazing up at the night sky and wondering what lies beyond our small blue planet. Tonight, we're going to explore one of humanity's most ambitious dreams and perhaps our most impossible challenge. We're going to journey to the nearest star beyond our Sun, Proxima Centauri, and discover why reaching this distant beacon might forever remain beyond human grasp. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination drift across the infinite void between stars. I'd love to know where you're listening from tonight. Feel free to comment your time and location below. There's something beautifully poetic about discussing interstellar travel while we're all scattered across different time zones on this tiny world, each of us dreaming of what might lie among distant suns. Picture yourself standing in your backyard on a clear night. Among the thousands of stars scattered across the darkness, there's one that you cannot see with your naked eye. It's a small red dwarf star called Proxima Centauri, and it holds the distinction of being our nearest stellar neighbor. At just over 4 light-years away, it seems almost tantalizingly close in cosmic terms. But here's the profound truth that we'll uncover together. Those 4 light-years represent a chasm so vast, so fundamentally challenging to cross, that it may forever separate humanity from the stars. This isn't a story about technology we haven't invented yet, or engineering problems we haven't solved. This is a story about the very fabric of reality itself, about the laws of physics that govern our universe, and about the humbling realization that some dreams may be beautiful precisely because they remain forever out of reach. Welcome to this journey through space and time, where we'll explore not just the distance to Proxima Centauri, but the profound challenges that distance represents. We'll discover why this journey isn't merely difficult, but may be fundamentally impossible for creatures like us, bound by biology, physics, and the cruel mathematics of interstellar space. Let's begin with something that seems simple, but reveals the first hint of our cosmic predicament. Proxima Centauri sits 4.24 light-years from Earth. Now, a light-year isn't a measure of time, despite its name. It's a measure of distance, specifically the distance that light travels in 1 year. And light, moving at roughly 300 million meters per second, covers about 9.5 trillion kilometers in a single year. So when we say Proxima Centauri is 4.24 light-years away, we're talking about approximately 40 trillion kilometers. To put that in perspective, if you could drive a car at highway speeds without ever stopping, it would take you over 40 million years to reach our nearest stellar neighbor. If you traveled at the speed of our fastest spacecraft ever built, it would still take tens of thousands of years. But the distance itself is only the beginning of our challenge. You see, Proxima Centauri isn't just far away. It exists in an environment so hostile, so fundamentally alien to human life, that the journey there reveals layer upon layer of seemingly insurmountable obstacles. The space between stars isn't empty. While it's often called a vacuum, interstellar space is filled with a thin soup of hydrogen atoms, cosmic dust, and radiation. This might not sound dangerous until you consider what happens when you're traveling at the tremendous speeds necessary for interstellar travel. Each tiny particle of dust becomes a bullet. Each hydrogen atom becomes a potential hazard. The faster you travel, the more destructive these encounters become. Imagine driving through a gentle snowfall at normal speeds. The snowflakes might dust your windshield harmlessly. Now imagine driving through that same snowfall at half the speed of light. Each snowflake would strike your vehicle with the force of a bomb. This is the reality of high-speed interstellar travel. The very medium through which we must travel becomes our enemy. Then there's the problem of radiation. Space is flooded with cosmic rays, high-energy particles that stream through the universe at incredible speeds. On Earth, we're protected by our planet's magnetic field and atmosphere. But in the depths of space, particularly during the decades or centuries required for interstellar travel, this radiation becomes a constant threat to both human biology and sensitive electronics. But perhaps the most fundamental challenge isn't the environment of space itself, but the physics of getting there. To reach Proxima Centauri in any reasonable time frame, we would need to achieve velocities that represent significant fractions of the speed of light. And here's where we encounter one of the most beautiful and merciless laws of the universe. As objects with mass approach the speed of light, several things happen that seem almost designed to prevent interstellar travel. First, the energy required to accelerate the object increases dramatically. It's not a linear relationship. The energy requirements grow exponentially as you approach light speed. By the time you're traveling at 90% the speed of light, you need more than twice the energy it took to reach 70%. By 99%, the energy requirements become truly astronomical. This creates what physicists call the relativistic energy barrier. It's not that we lack the technology to build fast enough engines. It's that the universe itself seems to conspire against high-speed travel for objects with mass. The faster you want to go, the more energy you need, and that energy requirement grows without limit as you approach the cosmic speed limit. But let's imagine for a moment that we somehow solved the energy problem. Let's say we found a way to accelerate a spacecraft to 10% the speed of light, which would get us to Proxima Centauri in about 42 years. Even this seemingly modest speed presents challenges that stretch the boundaries of what's possible. At 10% light speed, our spacecraft would be traveling at roughly 30,000 kilometers per second. That's fast enough to circle the Earth in about 13 seconds. At these velocities, every aspect of the journey becomes an engineering nightmare. Navigation becomes incredibly complex because the stars themselves appear to shift position due to relativistic effects. Communication with Earth becomes nearly impossible due to the vast distances involved and the Doppler shift of radio signals. And then there's the human element. A journey to Proxima Centauri, even at these tremendous speeds, would take decades. This isn't like the Apollo missions to the Moon, which lasted days, or even a mission to Mars, which might take months. We're talking about a significant portion of a human lifetime spent in the hostile environment of space. The psychological challenges alone are staggering. Imagine being confined in a small space with the same group of people for 40 years, knowing that you can never go outside, never breathe fresh air, never see a sunset, never feel rain on your face. The isolation would be complete and absolute. There would be no possibility of rescue, no chance to change your mind, no way to return home if something went wrong. The biological challenges are equally daunting. Human bodies evolved for life on Earth with its specific gravity, atmosphere, and radiation environment. In the microgravity of space, bones lose density, muscles atrophy, and cardiovascular systems weaken. These effects accumulate over time, and we simply don't know what decades in space would do to the human body. Then there's the problem of radiation exposure. During a multi-decade journey through interstellar space, travelers would be exposed to cosmic radiation at levels far exceeding anything experienced on Earth or even in low Earth orbit. This radiation doesn't just pose an immediate health threat, it damages DNA, potentially causing cancer and genetic mutations that could affect not just the travelers, but any children they might have. But perhaps the most sobering challenge is the simple matter of keeping humans alive for such an extended period. A journey to Proxima Centauri would require a completely closed ecological system. Every drop of water would need to be recycled. Every breath of air would need to be purified and reused. Every scrap of food would need to be carefully managed. There could be no waste, no inefficiency, no margin for error. The spacecraft would essentially need to be a miniature Earth, capable of sustaining human life indefinitely. We've never built anything even remotely approaching such a system. Our most advanced life support systems, like those on the International Space Station, still require regular resupply from Earth. Creating a truly self-sufficient ecosystem that could operate flawlessly for decades without any external input represents a challenge that may be beyond current human capabilities. And what happens when things go wrong? Because things will go wrong. Equipment will fail. Systems will break down. Unexpected problems will arise. On Earth, or even in Earth orbit, help is available. Replacement parts can be sent. Experts can provide guidance. Rescue missions can be launched if necessary. But a spacecraft traveling to Proxima Centauri would be completely on its own. The crew would need to be prepared to handle any conceivable problem with only the resources they brought with them. This means the spacecraft would need to carry not just spare parts for every critical system, but the tools and materials necessary to manufacture new parts when the spares run out. It would need multiple backup systems for every vital function, and the crew would need to be trained not just as astronauts, but as engineers, doctors, mechanics, farmers, and experts in dozens of other fields. The complexity of such a mission grows exponentially with each requirement we add, and we haven't even begun to consider what happens when we actually reach Proxima Centauri. The challenges of the journey itself are so overwhelming that they make the destination almost secondary. But those challenges at the destination add yet another layer of seemingly impossible requirements to an already impossible mission. As we continue to explore this cosmic puzzle, we'll discover that the barriers to reaching Proxima Centauri aren't just technological or biological. They're written into the very structure of reality itself, into the fundamental laws that govern space, time, and energy. The universe, it seems, has built-in protection against easy interstellar travel, creating obstacles that grow more daunting the more deeply we examine them. And here, we encounter one of the most profound paradoxes of interstellar exploration. The very technologies we would need to make such a journey possible also create new categories of problems that seem designed to humble our ambitions. Consider the propulsion systems required to achieve even modest fractions of light speed. The energies involved are so immense that they begin to approach the realm of natural phenomena we typically associate with stellar cores or cosmic catastrophes. Fusion rockets, often considered our most promising near-term technology for deep space exploration, would need to operate continuously for years or even decades. The fuel requirements alone present a mathematical nightmare. The more fuel you carry, the more mass you need to accelerate, which requires more fuel, which adds more mass, creating a spiral of requirements that quickly becomes absurd. Rocket engineers call this the tyranny of the rocket equation, and it becomes truly tyrannical when applied to interstellar distances. Even more exotic propulsion concepts like antimatter drives, while theoretically more efficient, introduce hazards that border on the incomprehensible. Antimatter is the most volatile substance in the universe. When it contacts normal matter, it annihilates completely, converting mass directly into energy with perfect efficiency. The amount of antimatter needed for an interstellar mission would be sufficient to destroy entire continents if it were released accidentally. Storing and controlling such quantities over decades of travel presents engineering challenges that may simply have no solution. Then there are the more speculative technologies that capture our imagination. Solar sails and light-driven spacecraft offer the tantalizing possibility of propulsion without fuel, using the gentle pressure of starlight itself. But the numbers tell a sobering story. To achieve meaningful velocities, such sails would need to be enormous, perhaps thousands of kilometers across, yet impossibly thin and perfectly engineered. The slightest damage from micrometeorites would be catastrophic, and controlling such massive structures across interstellar distances becomes an exercise in cosmic precision that exceeds our current understanding of engineering. But let's step back from the technical challenges and consider something even more fundamental. The journey to Proxima Centauri forces us to confront the nature of human identity itself. Who would we be after spending decades traveling through the void? The people who arrived at Proxima Centauri would be fundamentally different from those who departed Earth, not just because of aging, but because of the profound transformation that such an experience would inevitably create. Think about how much you've changed in just the past decade of your life. Now imagine spending that entire decade confined in a spacecraft, watching Earth dwindle to invisibility, seeing the sun become just another star among millions. The psychological impact would be unlike anything in human experience. We are creatures shaped by horizons, by weather, by the cycle of seasons, by the simple ability to walk outside and breathe fresh air. Strip all of that away for decades, and we begin to question what would remain of our essential humanity. The social dynamics of such a mission present equally daunting challenges. A crew large enough to maintain the genetic diversity necessary for a permanent colony would number in the hundreds or thousands. Managing the complex interpersonal relationships, conflicts, and social structures of such a group over decades becomes a problem in social engineering that we've never attempted. What happens when conflicts arise that threaten the mission? What happens when people fall in love, when children are born, when leadership disputes emerge? History shows us that even the most carefully planned expeditions can fracture under stress. The isolation and pressure of interstellar travel would amplify every human weakness, every personality conflict, every disagreement about priorities and goals. There would be no possibility of escape, no higher authority to appeal to, no way to separate conflicting parties. The crew would need to create and maintain a perfect society while traveling through the most hostile environment imaginable. And what about the children born during such a journey? They would know no world except the interior of the spacecraft. They would grow up without ever seeing a blue sky, without ever feeling wind, without ever experiencing the simple pleasure of walking on solid ground? How do we prepare them psychologically for a life they've never known? How do we maintain human culture and identity across generations when the context that created that culture no longer exists? These questions become even more complex when we consider that the journey to Proxima Centauri would be one way. The energy requirements for the trip are so enormous that carrying enough fuel for a return journey is simply impossible. Anyone who makes this journey would be leaving Earth forever, not just personally, but generationally. Their children and grandchildren would be born among the stars, with no hope of ever seeing the world their ancestors called home. This permanence adds a moral dimension to the challenge that goes beyond mere engineering. Do we have the right to make such a decision for future generations? Is it ethical to condemn people to life in the void between stars, even if that journey might eventually lead to the establishment of humanity among the stars? But perhaps the most humbling aspect of the Proxima Centauri challenge isn't the technical obstacles or even the human factors. It's the realization that we're attempting to cross a gap that exists on scales our minds struggle to comprehend. The universe operates on timescales that dwarf human experience, on distances that reduce our entire civilization to a mote of dust. When we look at Proxima Centauri through our most powerful telescopes, we're seeing light that left that star over 4 years ago. By the time any signal we sent reached that system, years would have passed. By the time any response returned, nearly a decade would have elapsed. This isn't just a communication delay, it's a fundamental disconnection from the concept of real-time interaction that defines human society. The mathematics of interstellar travel force us to think in terms that challenge our basic assumptions about exploration and discovery. Previous human expeditions, no matter how ambitious, operated within frameworks where rescue was possible, where communication with home remained feasible, where the journey could be measured in months or years rather than lifetimes. The distance to Proxima Centauri exists in a completely different category of challenge. It's not like climbing a higher mountain or diving deeper into the ocean. It's like trying to step outside the boundaries of human experience itself. Every solution we propose creates new problems. Every technological advance reveals new categories of obstacles we hadn't previously considered. And yet, as we contemplate these seemingly insurmountable challenges, something beautiful emerges from the impossibility. The very act of grappling with the journey to Proxima Centauri forces us to examine who we are as a species, what drives us to explore, and what we're willing to sacrifice in the name of discovery. It pushes the boundaries of our engineering, our biology, our psychology, and our philosophy. Perhaps the true value of dreaming about Proxima Centauri isn't in the destination itself, but in how the journey transforms our understanding of what it means to be human in a universe of unimaginable scale. The impossibility doesn't diminish the dream. It gives the dream its power to inspire us to become more than we currently are. As we drift deeper into this cosmic meditation, we begin to see that the barriers to reaching Proxima Centauri aren't just obstacles to overcome. They're fundamental features of the universe that shape the very nature of existence itself. The cruel mathematics of space and time that make interstellar travel so challenging are the same forces that created the stable planetary systems where life can flourish. The same physical laws that allow stars to burn steadily for billions of years creating the conditions necessary for complexity and consciousness to emerge. In trying to reach Proxima Centauri, we're not just pushing against technological limitations, we're pushing against the architecture of reality itself, against the very structure that makes our existence possible. And in that pushing, in that striving against the impossible, we discover something profound about both the universe and ourselves. The question of reaching Proxima Centauri becomes even more complex when we consider the fundamental nature of information itself. Every decision made during such a journey would need to be made with the knowledge that Earth's guidance is effectively lost to time. The simple act of asking mission control for advice becomes meaningless when the response takes 8 years to arrive. The crew wouldn't just be physically isolated. They could be informationally orphaned, cut off from the accumulated wisdom and real-time knowledge of their entire species. This information isolation creates cascading effects that ripple through every aspect of the mission. Medical emergencies that could be easily resolved with consultation from Earth's best doctors become potentially fatal when that expertise is years away. Technical problems that could be solved by tapping into humanity's collective engineering knowledge become crew-breaking challenges when the only resources available are those carried within the spacecraft's hull. But the isolation goes deeper than practical concerns. Human culture evolves constantly, shaped by new discoveries, changing perspectives, and the dynamic interplay of billions of minds. A crew traveling to Proxima Centauri would carry with them a snapshot of human civilization, frozen in time at the moment of their departure. While they journey through the void, Earth would continue to evolve, to discover, to change in ways that would make their cultural knowledge increasingly obsolete. By the time they reach Proxima Centauri, the Earth they left would exist only in memory and stored data. The world their signals would eventually reach would be inhabited by people who might think differently, who would have solved problems the travelers never knew existed, who would have developed technologies that could make the entire journey seem quaint and primitive. This temporal displacement isn't just a philosophical curiosity, it represents a fundamental severing of the connection between explorer and home that has never existed in human history. Previous explorations, no matter how remote or dangerous, maintained some thread of connection to the civilization that launched them. Messages could be sent, even if they took months to arrive. Rescue missions could be planned, even if they took years to mount. But the gulf between Earth and Proxima Centauri exists on scales that transform communication from a delayed conversation into a kind of temporal archaeology. Consider the psychological weight of sending a message to Earth, knowing that by the time it arrives, everyone you knew when you sent it might be dead. Consider receiving a message from Earth that was sent before your children were born, carrying news and greetings from people who existed in what feels like a different universe. The normal human experience of communication, of shared time and common reference points, simply breaks down across interstellar distances. Yet even if we could somehow solve the technical challenges, even if we could build spacecraft capable of surviving the journey, even if we could sustain human life for the decades required, we would face perhaps the most profound challenge of all: the question of what we would find when we arrived. Proxima Centauri is not our sun. It's a red dwarf star, smaller, cooler, and fundamentally different from the stellar environment that shaped life on Earth. Red dwarfs are notoriously unstable, prone to violent flares that can strip away planetary atmospheres and sterilize any worlds that might orbit them. The habitable zone around such a star exists much closer to the stellar surface than Earth's orbit around our Sun, meaning any potentially habitable planets would be tidally locked, with one hemisphere in permanent daylight and the other in eternal darkness. These aren't minor inconveniences. They represent fundamental differences in the nature of any worlds we might find. The dream of finding an Earth-like planet orbiting Proxima Centauri, while not impossible, seems increasingly unlikely as we learn more about red dwarf systems. We might journey for decades only to find worlds that are utterly hostile to human life, planets scoured by radiation, or perhaps no planets at all. But let's imagine the most optimistic scenario. Let's say we somehow overcome every technical challenge, survive the journey, and find a world that could potentially support human life. Even then, the challenges have only just begun. The energy required to slow down from interstellar velocities is nearly as great as that required to accelerate to those speeds in the first place. A spacecraft designed to reach Proxima Centauri would essentially be a one-way bullet, with no realistic possibility of orbital insertion or gentle landing. The deceleration problem represents yet another layer of seemingly impossible engineering. Traditional rockets are useless for this task because they would require carrying impossible amounts of fuel for decades just for the final braking maneuver. More exotic solutions like magnetic sails or fusion ramjets introduce their own categories of complexity and risk. The simple act of stopping when you reach your destination becomes a challenge that might be more difficult than the journey itself. And what if the travelers change their minds? What if decades into the journey, they decide the mission is too dangerous, the destination too uncertain, the cost too high? Unlike any previous human expedition, there would be no possibility of turning back. The energy expenditure and time investment required to reverse course would be prohibitive. The crew would be committed to their destination as completely as if they had been fired from a cannon. This irreversibility adds a weight to the decision that goes beyond anything in human experience. When previous explorers set sail for unknown lands, they carried with them the possibility of return, the option to retreat if conditions proved too hostile. The journey to Proxima Centauri would strip away that safety net, that psychological anchor that has allowed humans to venture into the unknown throughout our history. The mathematics of such a mission also reveal uncomfortable truths about resource allocation and human priorities. The cost of mounting an interstellar expedition would dwarf every previous human endeavor combined. The resources required could solve hunger, provide clean water, cure diseases, and address countless other pressing needs here on Earth. The ethical question becomes unavoidable. Is the dream of reaching another star worth the cost of neglecting immediate human suffering? This isn't just a matter of economics. It's a question about the nature of human ambition and the direction of our species' development. Are we explorers by nature, driven to push beyond every boundary regardless of cost? Or are we gardeners, meant to tend and perfect the world we already inhabit before reaching for new ones? The journey to Proxima Centauri forces us to confront these questions because the scale of commitment required is so absolute. Previous space missions, even the most ambitious, represented relatively small investments that could be justified as advancing human knowledge and capability. But an interstellar mission would require a commitment of resources so vast that it would fundamentally reshape human civilization in the process of attempting it. Perhaps most tellingly, the challenges of reaching Proxima Centauri illuminate the extraordinary improbability of our own existence. The same physical laws that make interstellar travel so difficult are responsible for creating the stable, long-term conditions that allowed life to evolve on Earth. The vast distances between stars, which seem like obstacles to exploration, are also protective barriers that shield developing civilizations from cosmic catastrophes. The universe appears to be structured in a way that makes the emergence of complex life possible, while simultaneously making contact between different instances of that life extraordinarily difficult. This isn't coincidence. It's a fundamental feature of the cosmic architecture that shapes everything from the formation of galaxies to the evolution of consciousness. As we contemplate the impossibility of reaching Proxima Centauri, we begin to understand that we're not just grappling with an engineering problem or even a biological challenge. We're confronting the basic structure of reality itself, the way the universe organizes space and time and energy to create pockets of complexity and meaning while keeping those pockets isolated from one another across vast gulfs of emptiness. The barriers that prevent us from easily reaching other stars are the same forces that created the conditions for our existence in the first place. In trying to overcome them, we're not just pushing against technological limitations, we're pushing against the very framework that makes consciousness possible. And in that struggle, in that reaching toward the impossible, we discover something profound about what it means to be aware, finite beings in an infinite cosmos. The paradox deepens when we consider that the very technologies that might make interstellar travel theoretically possible also amplify the dangers exponentially. Advanced propulsion systems capable of achieving significant fractions of light speed would essentially transform any spacecraft into a weapon of unimaginable destructive potential. The kinetic energy stored in a vessel traveling at even 10% the speed of light would be equivalent to thousands of nuclear weapons. Any malfunction, any collision with even the smallest debris could release energy sufficient to sterilize entire regions of space. This isn't merely a technical concern about spacecraft design. It represents a fundamental shift in the nature of human exploration itself. Previous expeditions, no matter how ambitious or dangerous, operated within bounds where failure meant the loss of the explorers themselves. But the energies required for interstellar travel push us into realms where failure could have consequences that ripple across star systems. We're not just risking the lives of those brave enough to make the journey. We're potentially weaponizing space travel in ways that could threaten any life we might encounter. The moral implications become even more complex when we consider the possibility of encountering other forms of life around Proxima Centauri. Our arrival wouldn't be a gentle first contact scenario beloved by science fiction. We would be approaching at velocities that make our spacecraft indistinguishable from cosmic projectiles. Any attempt to decelerate or change course would require energy releases visible across light years. From the perspective of any hypothetical observers, our arrival would appear less like exploration and more like an incoming cosmic catastrophe. This transforms the entire philosophical framework of interstellar exploration. We like to imagine ourselves as peaceful ambassadors carrying the best of human civilization to the stars. But the physics of the journey would make us appear more like harbingers of destruction. our very approach announcing our presence through energy signatures that dwarf natural phenomena. The dream of interstellar contact becomes haunted by the reality that the journey itself might preclude any meaningful communication or peaceful interaction. But let's venture deeper into an even more unsettling possibility. What if the journey to Proxima Centauri reveals that interstellar travel isn't just difficult for humans, but represents a fundamental barrier that shapes the development of all technological civilizations? The same physical laws that make such journeys nearly impossible for us would apply equally to any other species that might have evolved elsewhere in the galaxy. This possibility offers a sobering explanation for the famous Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial life and our complete lack of evidence for it. Perhaps the galaxy is teeming with intelligent civilizations, but they remain forever isolated from one another by the same barriers that make our journey to Proxima Centauri so challenging. The universe might be structured in such a way that consciousness can emerge and flourish, but cannot easily spread between star systems. If this is true, then our isolation isn't an accident of timing or technology. It's a fundamental feature of cosmic architecture. The spaces between stars serve as both protective barriers and prison walls, allowing life to develop in safety while preventing it from easily expanding beyond its birth world. Each star system becomes an island of potential consciousness, forever cut off from meaningful contact with its neighbors by gulfs of space and time that no amount of technological advancement can easily bridge. This perspective transforms our relationship with Proxima Centauri from a destination to be reached into a symbol of cosmic loneliness. Those 4 light years don't just represent distance, they represent the fundamental isolation that might define the existence of every thinking species in the universe. We look toward that distant red star not as explorers planning a journey, but as castaways on a cosmic island, forever separated from other islands by an ocean we cannot cross. Yet there's something profoundly beautiful about this isolation when we consider it from a different perspective. The same barriers that prevent us from easily reaching Proxima Centauri also protect the uniqueness and diversity of whatever life might exist there. If interstellar travel were easy, the galaxy might have been homogenized long ago by the first species to achieve spaceflight. The difficulty of the journey preserves the possibility that each star system has developed its own unique evolutionary experiments, its own approaches to the problem of existence. The cruel mathematics that make interstellar travel so challenging might actually be the universe's way of protecting the infinite variety of forms that consciousness might take. By keeping civilizations isolated, the cosmos ensures that each world can explore the full range of possibilities for intelligence, culture, and understanding, without interference from neighbors who might have taken different evolutionary paths. This isolation also preserves something precious about the human experience itself. Our struggles, our discoveries, our unique perspective on existence remain genuinely our own. We haven't inherited our understanding of the universe from some galactic civilization that solved these problems millions of years ago. Every insight we gain, every mystery we unravel, every step we take toward understanding the cosmos represents authentic human achievement. The impossibility of reaching Proxima Centauri means that whatever we become as a species, we become through our own efforts. Our art, our science, our philosophy, our dreams, all emerge from the unique conditions of our particular corner of the universe. We are not students in a galactic classroom. We are original thinkers grappling with fundamental questions for the first time. But this raises another profound question that strikes at the heart of human ambition. If the barriers to interstellar travel are truly insurmountable, does that mean we should abandon the dream entirely? Should we turn our attention exclusively to perfecting life on Earth, to solving the problems of our own world rather than reaching for others? The answer isn't as simple as it might first appear. The very act of contemplating the journey to Proxima Centauri, of pushing against its impossibility, drives us to develop technologies and capabilities that transform life on Earth. The challenges of creating closed-loop life support systems for interstellar voyages lead to breakthroughs in environmental engineering that could help address climate change. The problem of shielding travelers from cosmic radiation advances our understanding of medicine and materials science. The psychological research needed to understand isolation and confinement provides insights into human nature that benefit everyone. In this sense, Proxima Centauri serves a purpose even if we never reach it. It functions as what engineers call a design driver, a goal so ambitious and demanding that pursuing it forces us to exceed our current limitations. The star becomes less important as a destination than as an inspiration, a distant beacon that calls us to become more than we currently are. The mathematical impossibility of the journey also teaches us something profound about the nature of human dreams and aspirations. Not every goal needs to be achievable to be valuable. Some dreams are worth pursuing precisely because they exist at the edge of the possible, because they force us to grow in ways that more modest ambitions never could. When we study the challenges of reaching Proxima Centauri, we're not just planning a mission that will probably never happen. We're engaging in a form of cosmic meditation, using the vastness of space and the limitations of physics to examine our own nature and place in the universe. The impossibility becomes a mirror that reflects back our own limitations and possibilities, our own dreams and fears about what it means to be human in an infinite cosmos. This perspective suggests that the true value of contemplating interstellar travel lies not in the destination, but in the journey of understanding itself. Each barrier we identify, each challenge we analyze, each impossibility we confront, teaches us something new about the universe and our place within it. The process of grappling with the impossible becomes a form of education that transforms us regardless of whether we ever build a single spacecraft. Perhaps most importantly, the challenge of reaching Proxima Centauri forces us to confront our own mortality and the mortality of our species in ways that no other endeavor quite manages. The timescales involve dwarf individual human lifespans and challenge us to think in terms of generations, of civilizational commitments that extend far beyond any single lifetime. This long-term thinking, born from contemplating the impossible journey to distant stars, might be exactly what our species needs as we face the challenges of the next few centuries. Climate change, resource depletion, social inequality, and technological disruption all require thinking on timescales that extend beyond individual political cycles or corporate quarterly reports. The perspective gained from seriously considering interstellar travel could provide the framework for addressing these more immediate but equally complex challenges. In the end, the impossibility of reaching Proxima Centauri might be the most important thing about it, not because it defeats our ambitions, but because it shapes them in ways that make us more thoughtful, more capable, more aware of both our limitations and our potential. The star we cannot reach becomes the star that guides us toward becoming the kind of species worthy of reaching for the stars, even if we never quite grasp them. As we drift deeper into this cosmic contemplation, we begin to see that the barriers separating us from Proxima Centauri aren't obstacles to overcome so much as features of a universe designed to nurture consciousness while preserving its diversity and independence. The impossible journey becomes a teacher, and in learning why we cannot reach that distant star, we discover profound truths about what it means to be human in a cosmos vast beyond imagination. The challenge of reaching Proxima Centauri reveals itself as more than a technical problem when we consider the fundamental nature of time itself during such a journey. Einstein's theories of relativity, those elegant equations that govern the behavior of space and time, introduce complications that transform interstellar travel from difficult to nearly paradoxical. As a spacecraft approaches significant fractions of light speed, time itself begins to behave in ways that challenge our most basic assumptions about shared experience. For the travelers aboard such a vessel, time would pass more slowly relative to those remaining on Earth. This isn't science fiction or theoretical speculation. It's a measurable, predictable consequence of the universe's structure that has been confirmed countless times in particle accelerators and atomic clocks. Imagine departing Earth on a journey to Proxima Centauri at 80% the speed of light. From your perspective aboard the spacecraft, the journey might feel like it takes only 3 years, but when you arrive and attempt to communicate with Earth, you discover that nearly 7 years have passed for everyone you left behind. Your children have grown older than your subjective experience suggests they should be. Your friends have lived through years of experiences that you never shared. The Earth you left exists only in your memory. This temporal displacement creates a form of exile that goes beyond mere physical distance. You become unstuck in time, a visitor from your own species' past, attempting to communicate with their future. Every message you send to Earth carries with it the weight of temporal displacement, creating conversations between different moments in human history rather than between contemporary minds. But the relativistic effects become even more profound at higher velocities. At 95% light speed, your subjective journey time might compress to just over a year, while Earth experiences more than 13 years of separation. You become a time traveler in the most literal sense, skipping forward through your species' history while remaining psychologically frozen at the moment of your departure. The psychological implications of this temporal isolation are staggering. Human identity is fundamentally tied to our shared experience of time, our ability to grow and change alongside our communities, our families, our entire species. Strip away that synchronization, and you begin to question what remains of human connection. The travelers to Proxima Centauri wouldn't just be exploring space, they would be abandoning their place in the normal flow of human time. This temporal exile becomes even more complex when we consider that the journey would likely span multiple generations of travelers. Children born aboard the spacecraft would experience time dilation as their only reality. To them, the compressed time frame would feel normal, while Earth's temporal experience would seem impossibly stretched. These children would grow up literally living in a different temporal realm than the species that created them. The communication delays compound these temporal effects, in ways that make meaningful dialogue nearly impossible. Even traveling at significant fractions of light speed, the journey to Proxima Centauri would take years from Earth's perspective. During this time, any message sent between Earth and the spacecraft would face propagation delays measured in years, creating conversations where responses arrive to questions asked by people who may no longer exist. Consider the profound loneliness of sending a message to loved ones on Earth, knowing that by the time they receive it and respond, you will have lived through experiences they cannot share, made decisions they cannot influence, perhaps even died before their words of comfort or advice can reach you. The normal human experience of communication, of shared decision-making, of mutual support, simply breaks down across these temporal and spatial gulfs. The isolation becomes even more absolute when we realize that the travelers would be making decisions not just for themselves, but for all future generations of their lineage. The children born during the journey would inherit a destiny they had no role in choosing. They would be citizens of the void between stars, belonging neither to Earth nor to whatever they might find at Proxima Centauri. But perhaps the most haunting aspect of this temporal displacement is how it would affect human memory and cultural continuity. The travelers would carry with them a snapshot of human civilization, frozen at the moment of their departure. While they journey through the darkness between stars, Earth would continue to evolve, to discover, to create new art, new science, new understanding. By the time the travelers reach their destination, they would be cultural archaeologists, carrying ancient knowledge to a new world, while their home planet had moved on to entirely new chapters of human development. This creates a peculiar form of immortality and death occurring simultaneously. The travelers' cultural moment, their specific slice of human history, would be preserved perfectly in the amber of interstellar space, but it would also be completely severed from the living, evolving culture that created it. They would become living museums of a human civilization that no longer exists in the form they remember. The technological challenges add yet another layer of impossibility to these temporal complications. The spacecraft systems would need to operate flawlessly, not just for the subjective time experienced by the travelers, but for the objective time that passes in the universe around them. Computer systems, life support, radiation shielding, all would need to function for decades of real time while being maintained by people experiencing a compressed time frame. This mismatch between subjective and objective time creates maintenance and planning challenges that have no precedent in human experience. How do you train people to maintain systems for decades when their subjective experience of time makes those same decades feel like months or years? How do you plan for equipment failures that occur on timescales that don't match your psychological sense of duration? The energy requirements for achieving such relativistic velocities introduce their own impossibilities. As spacecraft velocity approaches the speed of light, the energy needed for each additional increment of speed grows exponentially. At 90% light speed, the kinetic energy of even a small spacecraft would exceed the total energy output of our Sun for entire years. At 99%, the energy requirements become truly astronomical, potentially exceeding the energy content of entire star systems. These aren't merely technological challenges waiting for better engineering solutions. They represent fundamental limits imposed by the structure of space-time itself. The universe appears to be constructed in such a way that achieving the velocities necessary for practical interstellar travel requires energy expenditures that approach the scale of cosmic phenomena. But the energy problem extends beyond propulsion into every aspect of the mission. The spacecraft would need to carry not just enough energy to reach relativistic speeds, but enough to maintain all life support systems, computers, communications, and other essential functions for the duration of the journey. This energy would need to be stored in forms that remain stable and accessible across decades of travel through the hostile environment of interstellar space. Nuclear fusion, often proposed as the most promising energy source for such missions, presents its own cascade of technical impossibilities. Fusion reactors require precise magnetic confinement systems, complex fuel handling, and sophisticated control systems that would need to operate flawlessly for longer than any human technology has ever functioned. The fuel itself would need to remain stable and accessible throughout the journey, while the reactor components would face constant bombardment from cosmic radiation and the stress of extreme acceleration. Even more exotic energy sources like antimatter introduce hazards that border on the incomprehensible. The amount of antimatter needed for an interstellar mission would be sufficient to destroy entire continents if released accidentally. Containing and controlling such quantities over decades of travel, while maintaining the precise systems needed to convert that antimatter into useful propulsion, represents an engineering challenge that may simply have no solution within the laws of physics as we understand them. The spacecraft itself would need to be more than a vehicle. It would need to be a completely self-sufficient world capable of supporting human civilization indefinitely. Every system would require multiple redundancies. Every component would need backup alternatives. Every possible failure mode would need to be anticipated and prepared for. The complexity of such a system grows exponentially with each requirement we add, quickly reaching levels that exceed our ability to design, build, or maintain. Consider that the International Space Station, humanity's most sophisticated attempt at creating a self-sufficient orbital habitat, still requires regular resupply missions from Earth. It cannot operate independently for more than a few months without external support. Scaling this up to a completely autonomous system capable of supporting hundreds or thousands of people for decades represents a qualitative leap in complexity that may be beyond human capabilities. The spacecraft would need to carry not just spare parts for every critical system, but the manufacturing capability to create new parts when the spares are exhausted. This means including entire industrial facilities, raw materials, and the expertise to operate complex manufacturing processes in the unique environment of interstellar space. The travelers would need to be not just astronauts, but also engineers, doctors, farmers, manufacturers, and experts in dozens of other fields necessary to maintain technological civilization. But perhaps the most sobering realization is that even if we could somehow solve every technical challenge, even if we could build spacecraft capable of reaching Proxima Centauri, the journey itself might fundamentally change what it means to be human in ways that make the original goals of exploration meaningless. The people who arrived at Proxima Centauri after decades of travel through the void would be shaped by experiences no human has ever had. They would have lived their entire adult lives in an artificial environment, cut off from every natural process that shaped human evolution. Their children would be even further removed from the terrestrial experience that created our species. By the time they reach their destination, They might be as alien to Earth-bound humans as any extraterrestrial species we might encounter. This transformation isn't merely cultural or psychological. The physical effects of long-term space travel, the genetic mutations caused by cosmic radiation, the adaptations to artificial gravity and recycled atmosphere could create physiological changes that persist across generations. The humans who reach Proxima Centauri might be literally a different subspecies from those who launch the mission. The irony is profound. In trying to carry human civilization to the stars, we might lose the very humanity we sought to preserve and expand. The journey itself becomes a metamorphosis that transforms the travelers into something new, something that might be better adapted to life between the stars, but fundamentally disconnected from the earthbound experience that created them. And what would they find when they arrived? Proxima Centauri is a red dwarf star prone to violent flares that could sterilize any planets in its system. The potentially habitable worlds we hope to find might be tidally locked, with one hemisphere in perpetual daylight and the other in eternal darkness. The environment they encounter might be so hostile to human life that the decades of travel would prove to have been for nothing. Even if they found worlds suitable for human habitation, the energy requirements for orbital insertion and landing would be nearly as great as those required for the original journey. A spacecraft designed to reach Proxima Centauri at relativistic speeds would essentially be a one-way projectile with no realistic possibility of gentle arrival. The travelers might reach their destination only to discover that they lack the means to actually land and begin the colonization they had sacrificed so much to achieve. These cascading impossibilities create a picture of interstellar travel that goes far beyond mere technical challenges. They suggest that the barriers separating us from Proxima Centauri might be fundamental features of the universe itself, written into the basic structure of space, time, and energy in ways that preserve the uniqueness and isolation of each world where consciousness might arise. The 4 light years between Earth and Proxima Centauri begin to seem less like a distance to be crossed and more like a protective barrier, a cosmic moat that ensures each instance of life and intelligence can develop according to its own unique possibilities, without interference from neighbors who might have taken different evolutionary paths. In contemplating these impossibilities, we discover that the true significance of Proxima Centauri might not lie in reaching it, but in how the attempt to understand that journey transforms our perspective on existence itself. The barriers that prevent us from easily traveling between stars are the same forces that created the stable, long-term conditions necessary for life to emerge and consciousness to develop. The universe appears to be structured as a vast garden where each star system can nurture its own unique experiments in complexity and awareness, protected by gulfs of space and time that ensure diversity and independence. The impossibility of reaching Proxima Centauri isn't a failure of human ambition. It's a feature of cosmic architecture that makes our existence possible while preserving the infinite variety of forms that consciousness might take throughout the galaxy. As we drift deeper into this realization, we begin to see that our isolation isn't a prison, but a sanctuary. Our separation from other stars not a barrier to overcome, but a condition to celebrate. In the space between impossibility and dreams, we find something precious. The knowledge that whatever we become as a species, we become through our own authentic struggle with the mysteries of existence, shaped by the unique conditions of our own corner of the infinite cosmos. Cosmos. Perhaps the most haunting revelation about our cosmic isolation emerges when we consider how the universe itself seems designed to protect developing civilizations from the very ambitions that drive them toward the stars. The physical laws that make interstellar travel so monumentally difficult aren't arbitrary constraints imposed by an indifferent cosmos. They appear to be fundamental safeguards that preserve the delicate conditions necessary for consciousness to emerge and flourish. Consider the exquisite balance required for life to develop on any world. Stars must burn steadily for billions of years. Planetary orbits must remain stable across geological timescales, and the complex chemistry of life must proceed without catastrophic interruption. The same vast distances that separate us from Proxima Centauri also shield developing worlds from cosmic catastrophes that could sterilize entire systems. Nearby supernovae, gamma-ray bursts, or the gravitational chaos of stellar collisions become manageable threats when filtered through the protective buffer of interstellar space. This cosmic architecture suggests something profound about the nature of consciousness in the universe. Rather than being an accident or anomaly, intelligence might be the inevitable result of a cosmos structured specifically to nurture complexity while preventing its premature destruction. The barriers that seem to imprison us within our solar system might actually be the walls of a nursery, protecting humanity's development until we reach some form of cosmic maturity we cannot yet imagine. But what would such maturity look like? Perhaps the answer lies not in overcoming the physical barriers to interstellar travel, but in transcending our current understanding of what exploration and expansion might mean. The human drive to reach beyond our current boundaries represents something deeper than mere wanderlust or territorial expansion. It reflects our species' fundamental relationship with mystery itself, our compulsion to push against the unknown until it yields its secrets. This drive has served us well throughout our history. It carried our ancestors out of Africa and across every continent on Earth. It launched us into the sky and eventually to the moon. But the challenge of reaching Proxima Centauri might be teaching us that physical exploration has natural limits, boundaries beyond which different forms of reaching become necessary. The information we gather about distant stars through our telescopes represents a kind of interstellar travel that circumvents many of the impossible barriers we've explored. When we analyze the light from Proxima Centauri, we're not just observing photons that have traveled 4 years to reach us. We're receiving messages encoded in wavelengths and spectra that tell us about stellar composition, planetary atmospheres, and the fundamental physics operating in distant systems. This electromagnetic archaeology allows us to explore the universe without ever leaving Earth's vicinity. Every photon that reaches our detectors carries information that would take decades or centuries to gather through physical visitation, if such visitation were even possible. In a sense, the universe comes to us through light, delivering knowledge across impossible distances at the only speed that makes such delivery feasible. But there's something both beautiful and melancholic about this form of exploration. We can study Proxima Centauri in exquisite detail, map any planets that might orbit it, analyze their atmospheric composition, and even detect potential biosignatures that might indicate the presence of life. Yet we remain forever separated from direct experience of these worlds by barriers that no amount of technological advancement seems capable of overcoming. This separation creates a unique form of cosmic longing that might be fundamental to intelligent beings anywhere in the universe. We are close enough to our stellar neighbors to know they exist, to study them, to wonder about them, but too far away to visit them or communicate with any intelligence that might exist there. It's as if the universe is structured to create eternal curiosity without the possibility of final satisfaction. The psychological implications of this cosmic architecture extend far beyond academic astronomy. When we truly grasp that we might be forever confined to our local stellar neighborhood, something shifts in our relationship with Earth itself. The pale blue dot that Carl Sagan wrote about so eloquently becomes not just our home, but potentially our only home for the entire future history of our species. This realization could lead to despair, a sense of cosmic claustrophobia that makes our terrestrial problems seem impossibly constraining. But it might also lead to something more profound, a recognition that the Earth represents not a launching pad for greater adventures, but the stage upon which the entire human drama must unfold. Every relationship we form, every work of art we create, every scientific discovery we make, every moment of joy or sorrow we experience happens within the context of this single world, floating in an ocean of unreachable stars. The impossibility of reaching Proxima Centauri transforms Earth from a starting point into a destination, from a place we might someday leave behind into the arena where we must discover what it truly means to be human. This shift in perspective doesn't diminish our cosmic significance. It concentrates it, forcing us to find infinity, not in the spaces between stars, but in the depths of our own capacity for understanding, creativity, and connection. But perhaps the most profound implication of our cosmic isolation is how it shapes our responsibility to the life that does exist within our reach. If we truly cannot escape to other worlds when we damage this one, if there is no backup planet waiting for us among the stars, then our relationship with Earth's biosphere becomes more than environmental stewardship. It becomes a sacred trust with the only life we may ever know. The same physical laws that prevent us from easily traveling to Proxima Centauri also ensure that Earth's ecosystem represents a unique and irreplaceable experiment in complexity and consciousness. Every species that goes extinct, every habitat that disappears, every disruption to the delicate web of relationships that sustains life on our world represents a loss that cannot be replaced by discoveries among distant stars. This perspective transforms environmental protection from a policy choice into a cosmic imperative. We are not just preserving Earth's environment for ourselves and our descendants. We are preserving what might be the only instance of complex life within our sphere of influence. The Amazon rainforest becomes more than a source of oxygen and carbon storage. It becomes a library of biological information that took billions of years to compile and might never be replaced if lost. The isolation that makes reaching Proxima Centauri impossible also makes every moment of consciousness, every flash of understanding, every experience of beauty or love infinitely precious. If we truly are alone in our local cosmic neighborhood, then human consciousness represents something miraculous. Matter that has organized itself to contemplate its own existence, to create art and music and poetry, to feel wonder at the sight of distant stars it can never reach. This consciousness doesn't require validation from alien civilizations to be meaningful. It doesn't need to spread across the galaxy to justify its existence. The simple fact that atoms forged in the hearts of dying stars have somehow arranged themselves into minds capable of understanding their own cosmic heritage represents an achievement so improbable and magnificent that it needs no external purpose to justify its value. Yet even as we accept the apparent impossibility of reaching other stars, the dream of Proxima Centauri continues to serve a vital function in human consciousness. It represents the horizon of possibility, the distant goal that calls us to exceed our current limitations, even if we never quite reach it. The technologies we develop in pursuit of impossible dreams often find applications we never anticipated, solving problems we didn't know we had and opening possibilities we couldn't have imagined. The medical research required to understand the effects of long-term space travel advances our knowledge of human physiology in ways that benefit everyone on Earth. The engineering challenges of creating closed-loop life support systems drive innovations in sustainability and resource management. The psychological studies needed to understand isolation and confinement provide insights into human nature that improve life for people facing difficult circumstances anywhere. In this sense, Proxima Centauri serves as what engineers call a design driver, a goal so ambitious and demanding that pursuing it forces us to become more than we currently are. The star becomes less important as a destination than as an inspiration, a distant beacon that calls us to push against our limitations, even when those limitations prove insurmountable. The mathematical impossibility of the journey also teaches us something profound about the nature of human dreams and aspirations themselves. Not every goal needs to be achievable to be valuable. Some dreams are worth pursuing precisely because they exist at the edge of the possible, because they force us to grow in ways that more modest ambitions never could. When we study the challenges of reaching Proxima Centauri, we're not just planning a mission that will probably never happen. We're engaging in a form of cosmic meditation, using the vastness of space and the limitations of physics to examine our own nature and place in the universe. The impossibility becomes a mirror that reflects back our own limitations and possibilities, our own dreams and fears about what it means to be human in an infinite cosmos. This process of grappling with the impossible serves as a form of education that transforms us regardless of whether we ever build a single spacecraft. Each barrier we identify, each challenge we analyze, each impossibility we confront, teaches us something new about the universe and our place within it. The journey of understanding becomes as valuable as any physical destination we might reach. Perhaps most importantly, the challenge of reaching Proxima Centauri forces us to confront our own mortality and the mortality of our species in ways that no other endeavor quite manages. The timescales involved dwarf individual human lifespans and challenge us to think in terms of generations, of civilizational commitments that extend far beyond any single lifetime. This long-term thinking, born from contemplating impossible journeys to distant stars, might be exactly what our species needs as we face the challenges of the coming centuries. Climate change, resource depletion, technological disruption, and social transformation all require thinking on timescales that extend beyond individual political cycles or economic quarters. The perspective gained from seriously considering interstellar travel provides a framework for addressing these more immediate but equally complex challenges. The cruel mathematics that make reaching Proxima Centauri so difficult also illuminate the extraordinary improbability of our own existence. The same physical laws that create barriers to interstellar travel are responsible for creating the stable planetary systems where life can flourish. The long-term stellar burning that provides consistent energy, and the complex chemistry that makes consciousness possible. In trying to reach Proxima Centauri, we're not just pushing against technological limitations, we're pushing against the very architecture that makes our existence possible. And in that pushing, in that striving against the impossible, we discover something profound about both the universe and ourselves. The barriers that separate us from other stars aren't obstacles to overcome so much as features of a cosmos designed to nurture consciousness while preserving its diversity and independence. Each star system becomes an island of potential awareness, protected by gulfs of space and time that ensure no single form of intelligence can easily dominate or homogenize the galaxy. This isolation preserves something precious about the human experience. Our struggles, our discoveries, our unique perspective on existence remain genuinely our own. We haven't inherited our understanding of the universe from some galactic civilization that solved these problems millions of years ago. Every insight we gain represents authentic human achievement, emerging from the unique conditions of our particular corner of space and time. The impossibility of reaching Proxima Centauri means that whatever we become as a species, we become through our own efforts. Our art, our science, our philosophy, our dreams all emerge organically from our encounter with the cosmos as experienced from Earth. We are not students in a galactic classroom. We are original thinkers grappling with fundamental questions for the first time. This authenticity of experience gives weight and meaning to every human achievement. When we decode the structure of DNA, or compose a symphony, or discover the expansion of the universe, we're not just adding to some universal database of knowledge. We're participating in the cosmos, coming to understand itself through the unique lens of human consciousness. The distance to Proxima Centauri, those seemingly impossible 4 light years, becomes not a barrier to transcend, but a boundary to celebrate. It marks the edge of our cosmic neighborhood, the frontier beyond which we encounter the fundamental limits that shape the structure of reality itself. In learning to live within those limits, we might discover forms of transcendence that don't require leaving our solar system behind. As you rest here, contemplating these cosmic truths, remember that you are part of this grand design. Every atom in your body was forged in the heart of a dying star. Every thought in your mind represents matter that has somehow learned to contemplate its own existence. You are the universe becoming aware of itself, a temporary arrangement of cosmic material that has achieved the extraordinary feat of consciousness. The barriers that prevent us from reaching Proxima Centauri are the same forces that created the conditions for your existence. In understanding why we cannot easily travel between stars, we glimpse something profound about the nature of the cosmos and our place within it. We discover that isolation might not be a prison, but a sanctuary. Separation not a barrier to overcome, but a condition that makes awareness possible. The impossible journey to Proxima Centauri teaches us that the most profound explorations might not require spacecraft or exotic propulsion systems. They might require only the willingness to contemplate the mystery of existence itself, to marvel at the improbable fact that consciousness has emerged from matter, and to find in our cosmic loneliness not cause for despair, but reason for wonder. In the space between Earth and that distant red star, in the gulf that cannot be crossed, we find not emptiness, but meaning. The very impossibility of the journey reveals the preciousness of the life we can touch, the relationships we can form, and the understanding we can achieve within the boundaries of our single, extraordinary world. Tonight, as you prepare for sleep, know that you rest under the same stars that have watched over countless generations of dreamers and explorers. The light from Proxima Centauri that left that star over 4 years ago is still traveling toward us through the darkness, carrying information across impossible distances at the only speed the universe allows. When it finally reaches Earth, it will tell us something about that distant world, but it will also remind us of something equally important, that we are part of a cosmos vast beyond imagination, connected to distant stars by light and gravity and the fundamental forces that shape reality itself. The impossibility of reaching Proxima Centauri doesn't diminish our cosmic significance. It concentrates it, focusing our attention on the miracle of consciousness in a universe that seems designed to make such awareness both possible and precious. In understanding why we cannot easily travel between stars, we discover why the journey of understanding itself might be the greatest adventure of all. The deeper we venture into this cosmic riddle, the more we discover that our imprisonment within the solar system might actually be the universe's most elegant design feature. Consider how the mathematical barriers to reaching Proxima Centauri mirror the same physical laws that allow complex chemistry to unfold over billions of years without catastrophic interruption. The energy scales that make interstellar propulsion so impossibly demanding are precisely calibrated to permit the slow, patient assembly of molecules into cells, cells into organisms, and organisms into minds capable of contemplating their own existence. This isn't coincidence, it's architecture. The universe appears to operate on a principle of protective isolation, creating conditions where consciousness can emerge and develop without premature interference from cosmic neighbors who might have evolved along entirely different paths. The 4 light years separating us from Proxima Centauri function as more than distance. They serve as a temporal buffer, ensuring that any signals or influences traveling between star systems arrive weakened by time and space, filtered through the natural limitations that preserve local development. Think about what this means for the nature of intelligence throughout the galaxy. If every star system faces similar barriers to interstellar expansion, then consciousness, wherever it arises, must develop its own authentic relationship with existence. There can be no galactic empire, no universal civilization that homogenizes the approaches to understanding reality. Each instance of awareness must grapple with fundamental questions using only the resources and perspectives available within its local cosmic neighborhood. This isolation creates something beautiful. Every world where consciousness emerges becomes a unique experiment in what it means to be aware. The art, science, philosophy, and dreams that develop around each star represent genuine discoveries rather than inherited wisdom. When human beings contemplate the nature of time, or create music, or wonder about the meaning of existence, we're not rediscovering truths that some ancient galactic civilization worked out millions of years ago. We're participating in the universe's ongoing attempt to understand itself through genuinely independent perspectives. The barriers that make reaching Proxima Centauri impossible also preserve the authenticity of human achievement. Every scientific breakthrough represents a real discovery, rather than remedial education. Every work of art emerges from humanity's unique encounter with existence, rather than following templates established by cosmic predecessors. Our struggles with questions of meaning, purpose, and identity reflect the universe genuinely exploring these concepts through the particular lens of terrestrial consciousness. But this isolation carries responsibilities as profound as they are sobering. If we truly cannot escape to other worlds when we damage this one, if there is no backup civilization waiting among the stars, then our stewardship of Earth's biosphere becomes more than environmental policy. It becomes a cosmic obligation to preserve what might be the only instance of complex life within our sphere of influence. The Amazon rainforest transforms from a regional ecosystem into a universal library. The migration patterns of Arctic terns become chapters in a story of biological complexity that took 4 billion years to write and might never be replaced if lost. Every extinction event removes not just a species from Earth's biosphere, but potentially eliminates a unique solution to the problem of existence that the universe spent geological ages developing. This perspective doesn't diminish human significance. It amplifies it beyond anything our species has previously imagined. We are not just biological organisms competing for resources on a small planet. We are the universe's attempt to understand itself through the medium of consciousness that emerged from 4 billion years of chemical experimentation. Every thought we think, every emotion we feel, every insight we achieve represents matter learning to contemplate its own existence. The cruel mathematics that prevent us from reaching Proxima Centauri also illuminate the extraordinary chain of cosmic accidents that made our existence possible. The precise calibration of fundamental constants that allows stars to burn steadily for billions of years. The gravitational dynamics that permit stable planetary orbits over geological timescales. The electromagnetic properties that enable complex chemistry to proceed without constant disruption. These same finely tuned parameters that created the conditions for consciousness also create the barriers that preserve its independence. The universe operates like a vast garden where each star system can nurture its own experiments in complexity and awareness, protected by natural moats that prevent any single approach to existence from overwhelming the others. The energy requirements that make interstellar travel so impossibly demanding serve as cosmic circuit breakers, ensuring that technological development cannot easily outpace wisdom. Any species that develops the capability to travel between stars must also develop the long-term thinking, social cooperation, and resource management skills necessary to sustain such ambitious projects across multiple generations. This creates a natural selection pressure for cosmic maturity. The barriers to interstellar expansion filter out civilizations driven by conquest, exploitation, or short-term thinking. Only species that have learned to think in terms of centuries or millennia, that have solved the problems of sustainable resource use and social cooperation, could even attempt to cross the gulfs between stars. Perhaps this explains why the galaxy appears so silent despite the billions of stars that could potentially harbor life. The same physical laws that make consciousness possible also ensure that it remains isolated until it achieves forms of maturity we can barely imagine. The great silence might not indicate the absence of intelligence elsewhere in the galaxy, but rather its presence in forms too patient and wise to attempt premature contact across interstellar distances. This possibility transforms our relationship with the search for extraterrestrial intelligence. We might not be alone in the galaxy, but we might be surrounded by civilizations so ancient and sophisticated that they have transcended the need for physical expansion or electromagnetic communication. They have learned to find infinity, not in the spaces between stars, but in the depths of understanding possible within their local cosmic neighborhoods. The barriers to reaching Proxima Centauri might be teaching us that true exploration doesn't require leaving home behind. The most profound journeys might be inward rather than outwards, focused on understanding the nature of consciousness itself rather than conquering new territories. The universe's structure seems designed to encourage this kind of exploration, creating conditions where awareness can deepen rather than simply spreading across space. Consider how the impossibility of interstellar travel forces us to confront the relationship between knowledge and experience. We can study Proxima Centauri in exquisite detail through our telescopes, analyzing its light to understand its composition, temperature, and behavior. We can detect planets orbiting that distant star, and even analyze their atmospheric composition. But we cannot touch those worlds, breathe their air, or walk upon their surfaces. This creates a unique form of cosmic knowledge based on inference rather than direct experience. We become archaeologists of light, decoding messages carried across impossible distances by photons that have traveled for years to reach our instruments. Every wavelength carries information about distant worlds, but it's information filtered through the medium of electromagnetic radiation and interpreted through the lens of human understanding. This separation between knowledge and experience might be fundamental to the cosmic order. We are close enough to other star systems to know they exist, to study them, to wonder about them, but too far away to interfere with whatever processes might be unfolding there. It's as if the universe is structured to create eternal curiosity without the possibility of premature contact. The psychological implications of this cosmic architecture extend far beyond astronomy. When we truly grasp that we might be forever confined to our solar system, our relationship with Earth undergoes a fundamental transformation. The pale blue dot becomes not a launching pad for greater adventures, but the stage upon which the entire human drama must unfold. Every relationship we form happens within the context of our shared cosmic isolation. Every work of art we create emerges from humanity's unique perspective as conscious beings confined to a single world. Every scientific discovery represents our species' authentic encounter with the mysteries of existence, rather than remedial education in principles established elsewhere. This confinement doesn't diminish the significance of human experience. It concentrates it, forcing us to find meaning, not in conquest or expansion, but in the deepening of understanding and the cultivation of wisdom. The barriers that prevent us from reaching other stars might be invitations to discover forms of transcendence that don't require leaving our cosmic neighborhood behind. The dream of reaching Proxima Centauri serves a crucial function, even if it remains forever impossible. It represents the horizon of human ambition, the distant goal that calls us to exceed our current limitations. The technologies we develop in pursuit of impossible dreams often find applications we never anticipated, solving problems we didn't know we had and opening possibilities we couldn't imagine. The medical research required to understand long-term space travel advances our knowledge of human physiology in ways that benefit everyone on Earth. The engineering challenges of creating closed-loop life support systems drive innovations in sustainability and environmental management. The psychological studies needed to understand isolation and confinement provide insights into human nature that improve life for people facing difficult circumstances anywhere. But perhaps the most important function of the Proxima Centauri dream is how it forces us to confront the nature of human longing itself. We are creatures driven by horizons, by the compulsion to push beyond every boundary we encounter. This drive has served our species well throughout history, carrying us from the African savanna to every continent on Earth and eventually into space itself. The challenge of interstellar travel might be teaching us that this drive for exploration can find expression in ways that don't require physical movement across space. The deepest explorations might be into the nature of consciousness itself, into the mathematical structures that govern reality, into the creative possibilities that emerge when matter learns to contemplate its own existence. The impossibility of reaching Proxima Centauri becomes a teacher rather than an obstacle, showing us that some barriers exist not to be overcome, but to be respected. The universe appears to be structured in ways that encourage the deepening of understanding, rather than its mere geographical spread. We are invited to become explorers of meaning rather than conquerors of territory. In contemplating the impossible journey to that distant red star, we discover that the most profound travels might be those that take us not to other worlds, but to deeper understanding of this one. The barriers that separate us from Proxima Centauri protect the uniqueness of human consciousness while challenging us to find in our cosmic isolation not cause for despair, but reason for wonder. The mathematics of interstellar travel reveal themselves as more than technical obstacles. They represent fundamental features of a universe designed to nurture consciousness while preserving its diversity. In learning why we cannot easily travel between stars, we glimpse something profound about the architecture of reality itself and our precious place within it. The 4 light years to Proxima Centauri begin to seem less like a distance to be conquered and more like a sacred boundary that defines the arena within which human consciousness can develop its unique relationship with existence. The impossible journey becomes not a failure of human ambition, but a feature of cosmic design that makes our awareness both possible and meaningful. As we drift deeper into this understanding, we recognize that the true significance of Proxima Centauri lies not in reaching it, but in how contemplating that journey transforms our perspective on what it means to be conscious beings in an infinite universe. The star we cannot reach becomes the star that guides us toward forms of exploration that transcend the need for physical travel, opening territories of understanding that exist not in the spaces between worlds, but in the depths of awareness itself. Yet, as we approach the final chapters of our cosmic meditation, something even more profound emerges from the mathematics of impossibility. The very forces that make reaching Proxima Centauri unattainable also reveal why consciousness might be the universe's most precious achievement, worth protecting behind barriers of space and time that ensure its delicate flowering remains undisturbed. Consider the exquisite timing required for awareness to emerge anywhere in the cosmos. Stars must burn with perfect steadiness for billions of years, neither too hot nor too cool, providing the consistent energy that allows complex chemistry to unfold with patient precision. Planetary orbits must remain stable across geological eons, creating environments where the intricate dance of molecules can proceed without catastrophic interruption. The fundamental forces must be calibrated with such precision that atoms can form, molecules can assemble, and eventually matter can organize itself into patterns complex enough to contemplate their own existence. These same delicate conditions that make consciousness possible also create the protective barriers that preserve its independence. The energy scales that render interstellar travel so monumentally challenging are precisely those needed to maintain the stable, long-term environments where intelligence can develop without premature interference from cosmic neighbors who might have evolved along radically different paths. This creates a universe that operates like a vast nursery for consciousness, where each star system becomes a protected laboratory for experimenting with the possibilities of awareness. The cruel mathematics that prevent us from reaching Proxima Centauri ensure that whatever forms of intelligence might exist around that distant red star can develop their own authentic relationship with existence, free from the overwhelming influence of more technologically advanced neighbors. The isolation isn't punishment or accident, it's design. A cosmos structured to maximize the diversity of approaches to understanding reality, where each instance of consciousness must grapple with fundamental questions, using only the resources and perspectives available within its local neighborhood. This ensures that when intelligence emerges, it emerges genuinely, creating original insights rather than simply inheriting solutions developed elsewhere. But this protective isolation comes with profound responsibilities that extend far beyond our individual lives or even our species' survival. If we truly cannot escape to other worlds when we damage this one, if there is no galactic civilization waiting to rescue us from our mistakes, then our stewardship of Earth's biosphere becomes a cosmic obligation of staggering magnitude. Every ecosystem we preserve maintains not just local biodiversity, but potentially the only complex life within our sphere of influence. Every species that goes extinct removes from the universe a unique solution to the problem of existence that took millions of years to develop and might never be replaced. The Amazon rainforest becomes more than a carbon sink. It becomes a library of biological information that represents billions of years of evolutionary experimentation. This perspective transforms environmental protection from policy preference into cosmic imperative. We are not just preserving resources for future generations of humans. We are maintaining what might be the universe's only successful experiment in complex life within our local region of space. The responsibility is both humbling and elevating, forcing us to recognize ourselves as temporary custodians of something infinitely precious. The same isolation that makes reaching other stars impossible also makes every moment of human consciousness extraordinarily valuable. In a universe where awareness might be rare and precious, every thought we think, every emotion we feel, every insight we achieve represents matter learning to understand itself through the unique lens of terrestrial intelligence. This doesn't require validation from alien civilizations to be meaningful. The simple fact that hydrogen atoms forged in the Big Bang and heavier elements created in stellar cores have somehow organized themselves into minds capable of contemplating their own cosmic heritage represents an achievement so improbable that it transcends the need for external purpose or comparison. When you look up at the night sky and feel wonder at the sight of stars you can never reach, you are participating in the universe's attempt to understand itself through human consciousness. That capacity for awe, for curiosity, for the recognition of beauty in distant lights represents something miraculous emerging from the interplay of matter and energy across cosmic time. The barriers that prevent us from easily traveling to Proxima Centauri also preserve the authenticity of every human achievement. When we decode the structure of DNA, or compose symphonies, or discover the expansion of the universe, we're not just adding entries to some cosmic database of knowledge. We're participating in genuine acts of creation, developing insights that emerge from humanity's unique encounter with existence. This authenticity gives weight and meaning to everything we accomplish as a species. Our art doesn't imitate galactic templates. It emerges from our particular way of processing experience. Our science doesn't rediscover ancient truths. It represents the universe genuinely learning about itself through terrestrial intelligence. Our struggles with questions of meaning and purpose aren't remedial exercises. They're original explorations of what consciousness might become. The dream of reaching Proxima Centauri continues to serve vital functions, even if it remains forever unattainable. It represents what engineers call a design driver, a goal so ambitious that pursuing it forces us to transcend our current limitations. The medical research needed to understand decades-long space travel advances our knowledge of human physiology in ways that benefit everyone on Earth. The engineering challenges of creating self-sufficient spacecraft drive innovations in sustainability and resource management that help us become better stewards of our own world. But perhaps most importantly, contemplating the impossible journey forces us to confront fundamental questions about the nature of human ambition itself. Are we explorers by essence, driven to push beyond every boundary regardless of cost? Or are we gardeners meant to cultivate and perfect the consciousness that has emerged within our cosmic neighborhood? The answer might be both. The same drive that makes us dream of distant stars also pushes us to explore the territories of understanding that exist not in physical space, but in the depths of awareness itself. The barriers to interstellar travel might be invitations to discover forms of exploration that don't require leaving our solar system behind. Consider how the impossibility of reaching other stars forces us to find infinity not in the spaces between worlds, but in the complexity that can emerge within a single planetary system. Earth's biosphere contains more diversity, more intricate relationships, more solutions to the challenges of existence than we could study in 1,000 lifetimes. The ocean depths remain largely unexplored. The quantum realm reveals new mysteries with every experiment. The human brain contains more neural connections than there are stars in the observable universe. The territories awaiting exploration within our cosmic neighborhood might be vast enough to occupy human consciousness for millions of years. We don't need to travel to other star systems to encounter alien forms of intelligence. We share our planet with countless species whose ways of processing information and responding to their environment differ radically from our own. We don't need to search distant worlds for exotic chemistry. The molecular machinery of life on Earth operates through mechanisms so elegant and complex that we're still discovering their fundamental principles. The impossibility of reaching Proxima Centauri might be teaching us that the most profound journeys are inward rather than outward, focused on understanding the nature of consciousness itself, rather than conquering new territories. The universe's structure seems designed to encourage this kind of exploration, creating conditions where awareness can deepen rather than simply spreading across space. This inward exploration doesn't diminish human significance, it concentrates it. Instead of being one species among countless others scattered across the galaxy, we become the universe's local experiment in consciousness, responsible for developing our own authentic relationship with existence. Instead of inheriting wisdom from galactic civilizations, we participate in the cosmos, genuinely learning about itself through the particular lens of terrestrial intelligence. The cruel mathematics that make interstellar travel impossible also ensure that whatever we discover about the nature of reality, we discover through our own efforts. Every insight represents authentic achievement rather than remedial education. Every breakthrough emerges from humanity's unique perspective, rather than following templates established by cosmic predecessors. This authenticity transforms every human experience into something precious and unrepeatable. The love you feel for another person doesn't echo galactic patterns of attachment. It represents consciousness exploring the possibilities of connection in ways that emerge from our particular evolutionary history. The beauty you find in music or art doesn't imitate universal aesthetics. It reflects the unique way human awareness processes pattern and meaning. As we drift toward the conclusion of our cosmic journey, we begin to see that the question of reaching Proxima Centauri was never really about transportation or technology. It was about understanding our place in a universe that seems designed to nurture consciousness while preserving its independence. The barriers that prevent us from easily traveling between stars are the same forces that created the conditions for our existence and that protect the authenticity of our experience. The 4 light years separating us from our nearest stellar neighbor represent more than distance. They represent the boundary of a cosmic sanctuary where human consciousness can develop its own relationship with existence, where our species can explore the full range of possibilities for awareness without interference from neighbors who might have taken entirely different evolutionary paths. In this sanctuary, every moment of consciousness becomes infinitely valuable. Every relationship we form, every work of art we create, every scientific discovery we make happens within the context of our shared cosmic isolation. We are not just biological organisms competing for resources on a small planet. We are the universe's attempt to understand itself through the medium of human awareness, temporary arrangements of cosmic material that have somehow learned to contemplate their own existence. The impossibility of reaching Proxima Centauri doesn't diminish our cosmic significance. It reveals why consciousness might be worth protecting behind barriers of space and time, why the universe might be structured to ensure that awareness, wherever it emerges, can develop according to its own unique possibilities without premature contact or interference. The star we cannot reach becomes the star that guides us toward deeper understanding of what we already possess. In learning why the journey is impossible, we discover why the destination might be less important than the consciousness capable of dreaming about such journeys in the first place. Tonight, as you prepare to drift into sleep, know that you rest under a sky filled with unreachable stars, each one potentially harboring its own experiments in consciousness, each one protected by the same barriers that preserve the uniqueness of human awareness. The light from Proxima Centauri that began its journey over 4 years ago continues traveling toward us through the darkness, carrying information across impossible distances at the only speed the universe allows. When that ancient light finally reaches Earth, it will tell us something about that distant world, but it will also remind us of something equally important. We are part of a cosmos vast beyond imagination, connected to distant stars by light and gravity and the fundamental forces that shape reality, yet isolated enough to develop our own authentic relationship with the mystery of existence. The impossibility of reaching Proxima Centauri teaches us that the greatest explorations might not require spacecraft or exotic propulsion systems. They might require only the willingness to contemplate the extraordinary fact that consciousness has emerged from matter, that awareness has learned to recognize itself, that the universe has developed the capacity to wonder about its own nature through minds like yours. In the space between Earth and that unreachable star, in the gulf that cannot be crossed, we find not emptiness, but meaning. The barriers that separate us from other worlds protect something precious. The knowledge that whatever we become as conscious beings, we become through our own authentic struggle with the mysteries of existence, shaped by the unique conditions of our corner of the infinite cosmos. And so, we arrive at the deepest truth about our cosmic predicament, one that emerges not from the failure of human ambition, but from the profound wisdom embedded in the architecture of reality itself. The barriers that make reaching Proxima Centauri impossible aren't obstacles waiting to be overcome by better technology or more clever engineering. They are fundamental features of a universe designed to protect the most precious thing it has ever created: consciousness itself. Think about the extraordinary chain of events that brought you to this moment, listening to these words under a sky filled with unreachable stars. 13.8 billion years ago, the universe began as a point of infinite density and temperature. From that primordial fire emerged the fundamental forces, the first particles, the cosmic background radiation that still whispers through space today. Stars formed and died, scattering heavy elements into the void. Planets condensed from stellar debris. And somehow, against odds so astronomical they defy comprehension, matter learned to contemplate its own existence. You are the temporary arrangement of atoms that achieved this impossible feat. The carbon in your cells was forged in the nuclear furnaces of dying stars. The oxygen you breathe was created when massive suns collapsed and exploded, seeding space with the elements of complexity. The hydrogen in your body dates back to the first moments after the Big Bang, when the universe was still hot enough to fuse protons and neutrons into the simplest atomic nuclei. This is your cosmic heritage, written in the very substance of your being. You are not separate from the universe, but part of its ongoing attempt to understand itself. Every thought you think, every emotion you feel, every moment of wonder you experience represents matter that has somehow transcended its own limitations to achieve awareness. The cruel mathematics that prevent us from reaching Proxima Centauri also preserve this miraculous achievement. The same physical laws that make interstellar travel so impossibly challenging are responsible for creating the stable, long-term conditions where consciousness could emerge and flourish. The energy barriers that doom our spacecraft to crawl through space at fractions of light speed are the same forces that allow stars to burn steadily for billions of years, providing the consistent energy needed for the patient assembly of complexity. The universe operates on a principle of protective isolation, ensuring that each instance of consciousness can develop according to its own unique possibilities, without interference from cosmic neighbors who might have evolved along entirely different paths. The 4 light-years separating us from Proxima Centauri function as more than mere distance. They serve as the walls of a sanctuary where human awareness can explore the full range of what it means to be conscious without premature contact or overwhelming influence from alien forms of intelligence. This isolation carries profound implications for how we understand our place in the cosmic order. We are not failed space travelers trapped on a small world by limitations we haven't yet overcome. We are the universe's local experiment in consciousness, responsible for developing our own authentic relationship with existence. Every discovery we make emerges from genuine exploration rather than inherited wisdom. Every work of art we create reflects our unique way of processing experience rather than imitating galactic templates. The barriers to interstellar travel ensure that human achievements remain authentically human. When we decode the structure of DNA or compose symphonies or discover the expansion of the universe, we're not rediscovering truths that some ancient galactic civilization worked out millions of years ago. We're participating in the cosmos, genuinely learning about itself through the particular lens of terrestrial intelligence. This authenticity gives extraordinary weight to every moment of human experience. The love you feel for another person doesn't echo universal patterns of attachment. It represents consciousness, exploring the possibilities of connection in ways that emerge from our specific evolutionary history. The beauty you find in a sunset or a piece of music doesn't reflect cosmic aesthetics. It manifests the unique way human awareness processes pattern and meaning. But with this isolation comes responsibility of cosmic magnitude. If we truly cannot escape to other worlds when we damage this one, if there is no galactic civilization waiting to rescue us from our mistakes, then our stewardship of Earth's biosphere becomes more than environmental policy. It becomes a sacred obligation to preserve what might be the universe's only successful experiment in complex life within our sphere of influence. Every species that goes extinct removes from the cosmos a unique solution to the problem of existence that took millions of years to develop and might never be replaced. Every ecosystem we destroy eliminates relationships and dependencies so intricate that we're still discovering their fundamental principles. The Amazon rainforest transforms from a regional resource into a cosmic library containing 4 billion years of biological research and development. The impossibility of reaching Proxima Centauri forces us to confront the relationship between human ambition and cosmic wisdom. Our drive to explore beyond every boundary has served our species well throughout history, carrying us from the African savanna to every continent on Earth, and eventually into space itself. But the barriers to interstellar travel might be teaching us that the deepest explorations don't require leaving our cosmic neighborhood behind. The territories awaiting discovery within our solar system dwarf anything we could find by traveling to distant stars. Earth's biosphere contains more diversity, more elegant solutions to the challenges of existence, more intricate relationships than we could study in millennia. The quantum realm reveals new mysteries with every experiment. The human brain harbors more neural connections than there are stars in the observable universe. Consider that we share our planet with forms of intelligence so alien that they might as well have evolved on distant worlds. The echolocation systems of dolphins operate on principles we're still trying to understand. The collective intelligence of ant colonies emerges from interactions too complex for our current mathematics to fully describe. The problem-solving capabilities of octopi suggest forms of consciousness that developed along completely different evolutionary paths from our own. Perhaps the most beautiful truth we've discovered tonight is that reaching Proxima Centauri was never really about getting there. It was about understanding why we can't, and in that understanding, finding something far more precious than any distant world could offer. The barriers that separate us from other stars aren't failures of human engineering or limitations waiting to be overcome. They're features of a cosmos designed to nurture consciousness while preserving its infinite variety. Tonight, as you drift towards sleep under these unreachable stars, remember that you carry within yourself the entire history of the universe. You are stardust that learned to dream, matter that achieved the impossible feat of self-awareness. The light from Proxima Centauri that began its journey years ago continues traveling toward us through the darkness, but perhaps the most extraordinary journey is the one that brought consciousness into existence right here, right now, in this moment of cosmic wonder. Sweet dreams, fellow travelers, in this magnificent, impossible, perfectly isolated sanctuary we call home.